Hello, chemists and scientists. Let's talk units of measurement. So, a unit of measurement is a definite magnitude of a physical quantity. What do I mean by physical quantity? Well, I could be talking about something like length, right? And we've got units such as centimeters or meters or feet or yards or miles to describe that length. So, all of those units describe that physical quantity of length, but they also represent different magnitudes. Volume, units such as cubic centimeters or milliliters, liters, gallons, quarts, again describing the physical quantity of volume. Pressure, units such as atmospheres or bar, torr, pascals to describe some quantity of pressure. Speed, well, units such as meters per second, let's say, or miles per hour to describe the magnitude of speed. Time, seconds, hours, years. Energy, joules or electron volts to describe some magnitude of energy. So we have a host of units, matter of fact, a whole host of units that might describe the same physical quantity, but they might describe different magnitudes of that quantity. Now, oftentimes units fall into English units versus international system or metric system. For instance, in the English units, common units are pound for weight or feet for length or gallon for volume. In the international system, kilogram for mass, meter for length, cubic meter, which is just a derived unit, for volume. Now, in terms of, like I said before, in terms of a physical quantity, you could have multiple units that describe that same physical quantity, although they describe different magnitudes. So for instance, if we're talking a physical quantity such as length here, we might use units of angstroms or meters or inches or centimeters or miles or kilometers. And by the way, this table is by no means extensive. Quick online search and you probably find significantly more extensive tables. Pay attention also to the abbreviations that I'm using here. M for meters or centimeters, cm, kilometers, km, miles, mi, or inch, in. I'll be using those types of abbreviations later when we're doing unit conversion. We also have some for mass. We've got some units for volume. I already mentioned a few of these. In chemistry, if we're talking masses, very common to be referring to masses in grams or kilograms. If we're working with volumes, liters, cubic centimeters, or milliliters are very popular volumes to work with. Now, what's also listed in this table, and I haven't really mentioned it, the way that these units are listed, they're listed as conversion factors. In other words, 1 angstrom is equal to 10 to the minus 10 meters. This gives me a way of converting my scale of angstroms into meters. Now, an angstrom is actually quite small. 10 to the minus 10 meters is a meter is about 3 feet long. So 10 to the minus 10 meters is a very, very small number. So angstrom becomes very convenient when we're talking the length scales that we certainly would encounter if we're talking about atoms or molecules. Again, we've got conversion factors between inches and centimeters and so on. Now, these conversion factors, we'll be using these quite a bit when I talk about the metric unit prefixes in the next video and conversion factors in a later video. One thing I also want to point out here in this very last column is I've listed what are called the exact or inexact conversion factors. Exact means these conversion factors have an infinite number of significant figures. So I've made a couple of videos on significant figures. If you haven't seen those, it might be worthwhile to go back and take a look at those. But if you're using these conversion factors in a calculation, they can certainly impact the number of significant figures you have in your final answer. However, those conversion factors that are exact and have an infinite number of significant figures, they won't impact your final answer, the number of significant figures in your final answer. The inexact ones could. Now, for instance, this one has 7 numbers. This would actually have 7 significant figures. This has 6 numbers here. This has 6 significant figures. Possibly, these could impact the number of significant figures in a calculation that you might be using these in. But anyways, this last column is just the exact and inexact is referring to the number of significant figures in that conversion factor. Now, we also have some other conversion factors. I had mentioned in that first slide, physical quantities such as pressure. Atmosphere, very popular unit. Matter of fact, 1 atmosphere is approximately the pressure that's pushing down on you on the surface of the Earth from the atmosphere above you. But again, other units that might be used would be bar or torr or pascals. All of these conversion factors allow us to convert from one unit to the next as necessary. And matter of fact, these are exact definitions again. So infinite number of significant figures in those conversion factors. Frequency, we'll be dealing with frequency and hertz quite a bit when we start talking about waves, and we're getting to wave mechanics and atoms. And we also have units for temperature. And some of you certainly have heard of these or worked with these, at least even listening, let's say, to the local news. So if for instance, if we wanted to take a temperature in degrees Fahrenheit, we simply subtract 32 from it, multiply by 5/9, and we got our temperature in degrees Celsius. If you wanted to go backwards and you're given a temperature in degrees Celsius, it just requires a little bit of algebra to solve for the temperature in degrees Fahrenheit. In terms of chemists and probably science in general, Celsius and Kelvin scales are the temperature scales that are used most frequently. So if you wanted to convert a temperature in degrees Celsius to a temperature in Kelvin, you simply add 273.15. And if you want to go in the reverse direction, if you were given a temperature in Kelvin and wanted the temperature in degrees Celsius, simply subtract 273.15 from your temperature in Kelvin. So, like I said, many units that could be used to describe the same physical quantity, they're going to describe different magnitudes of that quantity, and we're going to be using these as conversion factors later when we start taking a look at unit conversion and dimensional analysis. So I hope you found this video useful. Thanks for watching.